Hi, Year 5, good morning, and how are you today? Today we'll be studying math and we'll be having a review on lesson 12. Today we'll see how to read and construct graphs and also frequency tables, pictograms, and bar line charts. Let's see how to read and interpret graphs. Remember, when we did this lesson, I said to you that graphs are just representing information about an event, but it is being represented through a drawing, like the line graph, the bar graph, the pictogram. Remember the pictogram? And also, there's one more. We have the bar line graph, the line graph, we have the pictogram, and then we have the tally. Remember the tally? That's the frequency table. Okay, so always bear in mind that whenever you see a graph, it is just giving an information about an event to you through a diagram. Now, if you have to read a graph clearly, you need to take note of the following points. What is the title of the graph? Check the title. It will help you to know what the graph is describing or talking about. Here is the title of this graph, for example. The second thing is check the scales of the graph so that you can know what each scale represents. Do you remember the scales? Vertical and horizontal axis? Here is our vertical axis and here is our horizontal axis, just as it has been labeled. What do we have on the vertical axis? Or on the horizontal axis, we have the hours, and on the vertical axis, we have the number of customers. Now, if I look at this carefully, I will know, or it will interpret to me that this graph is talking about the number of customers that shop in Carrefour at different hours. So I can plot the graph having this information. What other thing do we need to do? Connect the vertical and the horizontal scale based on the data that you have been given. The data is usually that one that you have in the table that gives you all the numbers. Okay, so connect the vertical. You remember how we plot the graph, check the numbers, connect the two, put the dots, and then start connecting the lines. Now we've seen how to read a graph. What about how to construct a graph? Let's start with the line graph because we did mostly the line graph. We have a graph here, the same graph talking about the number of customers that shopped in Carrefour. Now, let us see the things we need to take note of. You have to study the data provided to you. If you don't understand that data, you will not be able to construct a good graph. What data am I talking about here? Here is the data. It says below is the number of customers who shopped at Carrefour at different hours. Remember when we were doing the student book and the workbook, we came across a lot of this. Before you see the graph, you would have seen this table first. The information will be provided to tell you how to plot the graph or how the graph was plotted. So here is the information for this particular graph. So study the data carefully and then you'll be able to plot your graph successfully. What's the next thing you need to do? Give a title to your graph. Now, with this information we have here, what title can we give the graph? Shoppers at Carrefour at different hours. Whatever title you feel suits the graph, put the title there. It's not enough for you to plot the graph. You also have to put the title of the graph. Then you have to choose and arrange your scale. Remember the scales, the vertical axis and the horizontal axis. With this information now, you need to set up the scale for your vertical axis and the scale for your horizontal axis. Now we have 350 as the least number on the scale for the number of customers, or on the table rather. And no, 300 is the least number and the highest number is 800. Now you can choose your scale from any number from 350 to 800, or any number maybe lesser than 350 or 300, sorry, to 1000. The numbers that you'll be using on your scale must contain the least number in your information and the highest number. So our least number is 300 here. The highest number is 800. Look at our vertical axis scale. Starts from 200 and ends at 1000. So it will be able to accommodate 300, which is the least number on our information, and it will also be able to accommodate 800, which is the biggest number. So this is a very good scale. What about the vertical or the horizontal axis? Look at it. We have from numbers 2, 4, 6, 8, and 10. Also, we have made provision for in between, in between the numbers, or in between each number, you could see that there would be definitely 3 in between 2 and 4. 5 will definitely be the middle number between 4 and 6, and so on. So it will be easy to plot this graph. Also, make sure the units between each two numbers on your scale is the same. You cannot do 200 on your vertical axis and the next number will be 600, and then the next one again will be 800. No. Now you see on our vertical axis, the difference between each of the numbers is 200, and it is like that till the end. The difference between the numbers on our horizontal axis is 1, and it is 2 rather. Between 2 and 4, 4 and 6, it's consistent, and this is how a good graph can be constructed. Finally, construct your graph, and you have a perfect graph. Now let's see other ways that we can represent data. We've seen the line graph. What other ways can we plot graphs, or what other ways can we represent data? We have a frequency table. Remember this? Each time we talked about the frequency table, you guys used to remember tally. Now, whenever you remember tally, just know that we're talking about the frequency table. It shows how frequently each information appears, how frequently each number appears. For example, on this table, we can see that the number that appears most is 2. The highest frequency is 2 because 2 appears 9 times. And which one appears the least time? 6. 6 appears only 2 times. So this shows information about how frequently a number appears. Then the pictogram. Remember that we said the pictogram shows pictures. It shows information using pictures. And finally, the bar line graph. That's the project that we have. The bar line graph shows information using bars. You see, it's different from the line graph. It uses bars instead of dots and lines. Now let's go ahead to units 3 and 4. Changing the scale on the vertical axis and describing the occurrence of familiar events. How do we change the scale on the vertical axis? Let's study from student book page 217. When we did this particular exercise or this particular lesson, I said to you that the information we have here on these two graphs are the same. The only thing that was done was the number on the vertical axis scale was changed on the second graph. So the first graph has numbers with intervals of 100 on the vertical axis, 400 to 500, 500 to 600, 600 to 700. There is a 100 interval, 100 unit interval on the vertical axis scale. Now, what did this writer of this book do? Came to the second graph and changed the scale to an interval of 500 from an interval of 100. So you can see it is still the same information represented, but the scale has been changed. And do you notice any difference in the graphs? You probably might think that the graph is different, but it's the same. The only thing this one does is it doesn't make the difference within or between each month to be too much. Look at the first graph, February and March. It seems like the difference between the 2 months is too much. But in the second graph, it covers it up. It doesn't make it look as if there's so much difference between the 2 months. So, the vertical axis can be any numbers between 0 and the highest units in our data. Just like I explained to you earlier, your numbers or your scale must be able to accommodate the smallest number on your data or on the table that you are provided with, and the biggest number also. Then the number you add up to make the next number must be the same. I also said that in the previous slide. If you're choosing a 100-unit scale, let it be 100, all true. If it is 200, let it be 200, all true. And finally, when you change your scale, you only increase or reduce the number on your vertical axis. You're only either reducing the number from units of 100 to maybe 50. For example, this is 400 to 500, 500 to 600. If you want to change it, you can change it to 450 to 550, 550 to 650. So that is exactly what you're doing. You're only changing the numbers on the vertical axis scale. Now let's see the chance or likelihood that an event will occur. This is the last unit in this lesson. The words we'll be using are impossible, unlikely, even, likely, and certain. We did this lesson for about a week and we were able to get the idea of describing the likelihood that an event will occur or not. Let's see impossible. For impossible, it means that the event cannot occur. There's no chance that it will happen. For example, I have a basket of oranges. Is it possible for me to pick an apple from the basket full of oranges? No way. So it means the event is impossible. Let's look at unlikely. For unlikely, it means that there is more chance that it will not happen than the chance that it will happen. It means that the likelihood that the event will happen is very little. Okay? For example, can we have rain during the cold summer period? Like, have you noticed that recently the sun has become very hot? Okay, now during the deep or the cold summer period, it's unlikely to have a rain. It can actually rain just like it happened the last time. You remember when we were having the Zoom class? Okay, now it's possible that it happens, but because right now the hot season has really come by, it may not happen. Okay, so we can say it's unlikely to happen. What about even? Even means that the event can happen or cannot happen. It's either it happens or it does not happen. The chances that it will happen is 50%, and the chances that it will not happen is also 50%. The chances are equal. Okay? Now, what is the chance that I will get an odd number if I toss a die? You know what a die is? This is a die. So, if I'm playing a game and I toss the die, a die has 6 sides. 3 sides have even numbers. 3 sides have odd numbers. So if I toss it, it is either it goes on the even number side or the odd number side. So it's even. We can say such an event is even. Only one of the two can occur. And what about this? Likely. Let's see likely. It means that the event is very likely to occur. Very likely to occur means that it's there are chances that this event will occur. Okay, like a whole day of rain during the winter. It's winter period. It's possible to have a whole day of rain during the winter. Very possible. Okay, so it's something we can say is likely. It doesn't mean that it will happen, but it is a possible thing because it is winter season. So it's possible. It's likely for it to happen. And finally, certain. Certain is it must. There is no other option. It will definitely happen. Like I hold a stone and I drop the stone. What is the likelihood that it will drop on the floor? Where else would it have dropped? Only on the floor. Look at this example. The news will be broadcast tonight. Every night the news is broadcast. So this is a certain event. Certainly it will happen. So thank you, Year 5, for listening to the lesson. I hope you enjoyed the lesson, and if you have any questions, please forward them to me on Class Dojo. So we have another lesson. Take care of yourselves and have a great day. Bye.